Hi, welcome to my latest video. Today I'm going to be having a look at the electrical auxiliary heating element which lies behind here somewhere. This is what's known as the PTC heater, or positive temperature coefficient. It is an electrical booster heater, and the idea is that it comes on automatically when it's very cold and gets the heater sort of air, the air coming out of the vents, warmed up quicker than the engine will heat them up. What does it actually look like? Here we go. I bought one of these secondhand on eBay. So this is what it looks like. We've got some large high current terminals there, and there's also some sort of signal connector there which turns it on or off. So yeah, I don't think mine's working. I don't know, it might be working, maybe it is working, but it just doesn't actually make the air blow very hot. What I would like to do is dig down, find my auxiliary heating element, actually check that it's got 12 volts and try and find this connector here, which I believe is on the other side, and actually see what's going on with that one, what voltages we've got sent to that. So I've done a bit of reading up. Here's a screenshot of the wiring diagram. So we can see from the wiring diagram that the main high current 12 volt connection here is actually permanently connected to the battery via a 100 amp fuse. This terminal here is permanently connected to ground, so the heater actually has a 100 amp supply permanently connected to it. Why doesn't it run all the time and drain your battery in a matter of seconds? It's because of this little connector here. So this connector here has 3 pins, and one of those pins is ground, one comes on with the ignition, and the other one is labelled as PWM, so that's pulse width modulation. Okay, so that is a square wave pulsing on and off rapidly, and the length of the on part of the pulse will vary compared to the off part, and the percentage that it's on will control how much heat comes out of the heater. It's worth mentioning though that they call this a positive temperature coefficient heating element. What does that actually mean? Well, it means that as the temperature increases, the resistance also increases. So it should never encounter a thermal runaway situation. As it gets hot, it draws less current and less power and heats less. So it will naturally reach a sort of optimum temperature where the resistance is increasing, the current is falling off, and it won't go any hotter. How hot it gets, I have no idea at all. Would have thought it would be pretty hot actually to actually heat up freezing cold air coming into the car. What I'd like to try and do is try and rig this one up on the bench and see if I can actually get it to turn on. Before I do that, I'm going to remove these side panels on the center console here and on the other side in the footwells, and have a look at the heating element, see if we can actually get to it, see if it's got 12 volts, see if I can access that 3-pin signal connector, and I will also check the 100 amp fuse. Okay, so underneath here, under my air horns here, there's the fuse box, and there is a special fuse in there. Now, there were reports of Freelander 2s catching fire due to the auxiliary heater. So Land Rover removed the fuse on a lot of cars. So if your auxiliary heater isn't working or you don't believe it's working, the first thing to check is the fuse. So what I'm going to do here is I'm just going to lift out my quick release air horns. If you're interested in those, there's another video showing the project to develop and fit those. And remove this. Now if we have a quick look at the picture on the back of here, we can see, so it's not that, F4 is glow plugs, it's this one here. A sort of car with some nice warmth radiating from the floor. 100 amps, F16, okay, F16. Now, it's not one of these type of fuses, okay, it is not that type, nor is it the mini type. It is a special fuse down the side. Now to extract the cover and get at the fuse, you need to get a small screwdriver. Okay, so small flat blade screwdriver, and well, you really need two of these actually. What you have to do is stick it down in there and there, and whilst pressing the little clips, there are some little barbs there that hold this piece in. Eventually, if you try and lift that whilst pressing the two tabs, and you do need 3 hands in order to do it, that comes off. Okay, now that isn't the fuse, that's the cover. The fuses are there. Okay, now remember that these are wired permanently to 12 volts. There is a very large red cable feeding them, so this top bit here is permanent 12 volts and it's not fused, so don't get any metal tools anywhere near that. This fuse here is F16. Okay, so you can actually see, if I try and move my phone in there, you can see there's a 100, and then you've got 60, 60, 60, 60, 60. So the other ones are feeding things like the central junction box, various control modules, whatever else, the fans, things that draw a reasonably high current. Everything else is run by these little tiny 10, 5, 15 amp fuses here. So these ones tend to feed the sort of main control modules in the car, and that 100 on the end there is our fuse for the auxiliary heater. Okay, so what I'm going to do now is get my meter. Okay, let me just get my meter set up, and I'll test the resistance of that fuse. I'll also test it for 12 volts and just make sure that 12 volts is appearing on the other side of the fuse. Okay, so I've just connected my meter negative probe there, and I've set it to the beep. Okay, so this is resistance setting. If it's under about 200 ohms, we should hear a beep. Okay, so it doesn't matter that this is live because this is just a resistance test. Okay, so even though there's 12 volts on this, the meter is measuring the resistance between the two probes. Okay, so if we do that, and that's interesting, touching that, and okay, right, now we've got a low resistance. It's not enough to make the beep beep, so there we go, there we go. Okay, right, I think what it is these nuts here are galvanized or something, or coated with something. Maybe they've been sprayed with some sort of lacquer or oil. They are a little bit difficult to get a connection through. Okay, so the fuse is making a low resistance connection through it, which means that it's not blown. Just to be really sure, I'll just put this meter to the 20 volt DC range, and if I can find a ground point, let's connect that carefully. So it's very difficult, it's very fiddly, and I'm very wary of. Right, let's see if we can find a ground connection. Right, there's one. So I'm just going to connect that onto there. Okay, let's just make sure we've got 12 volts. Yeah, okay, so that's on there. So what I want to do is get that down to the other one. Yeah, there we go. Absolutely spot on, 12 volts. Okay, so there's 12 volts coming out the other side of the fuse. So that would suggest that the auxiliary heater has 12 volts across it already. I mean, we'll check that when I actually dig in to find the heater. So the fuse isn't blown. The heater, we think, has 12 volts. It doesn't seem to be coming on though. So maybe something's going on with the control wires. Maybe the heating element is gone, maybe it's blown and it just doesn't work. So we'll put all this back together now. Now put this back on. You've got to make sure that things are lined up right. So this bit here, you make sure that's sort of sliding up and down, and then there it is. It clips back in. Okay, so it must go all the way down. And then just try and lift it again if it shouldn't come back up. Okay, so let's pop this back together. There we go. Quick release air horns back in. There we go. Okay, let's take all this round. So I've actually finished with the engine compartment side of things, and we'll move on round to the inside of the car. What I'll do is remove that panel and the one on the other side. So I'll get some tools out, we'll remove that and have a look what's behind. Okay, so there's one screw up in there, and it's a 7mm socket on the head of that screw. You take that out and then this all comes out. Now it is normally clipped in, okay, by some metal spring things. That one's broken off on mine, that one's still there. So you might find that you end up with one of the clips breaking off and leaving itself embedded in the remaining piece of the center console. That is the positive wire, okay, for the auxiliary heating element. You can't really see the element very easily. It's sort of hidden away in there. So what I will do now is see if I can get to take that. I'll see if I can pull that plug off, and we'll just make sure we've got 12 volts all the way down to the heater. And I'll remove this panel on the other side, and we'll make sure we've got a ground connection, and see if I can get at that 3-pin control connector. Okay, so what I've done now is I've pulled off that red connector and connected my meter to that, and the ground probe is just clipped onto the chassis metal body there of the heater, and we've got 12 volts pretty much. Okay, so that proves that the 12 volts is getting all the way down to the auxiliary heater. So the fuse is fine, the cabling is fine. We now need to have a look at the other side and see what's going on over there. Okay, so over on the other side, on the UK passenger side, I've just removed this panel. Again, one screw with a 7mm head, both clips intact on this one. And this is what we can see on this side. So there you can see that blue thing is the top of the negative connection, the 0 volts ground connection for the PTC heater. And just behind it you can see another cable, this one here, which has got 3 wires, and that is the signal connection, and that's really the connector that we need to pull off and have a look and see what's going on inside that connector. What I'm going to do first though is just prise this one off and just measure the resistance, make sure there's 0 ohms between this and the bodywork of the car, and make sure that there isn't a high resistance on the negative side. Right, I'm just going to check the resistance from this black plug here down to the body. So I've got my meter there set up on the beep continuity test, and let's just, right, there we go. Okay, so that plug there has a good connection to ground. Let's see if we can now dig in a little bit further. Right, this is going to be really difficult. Very, it's not accessible at all. I'm going to try and reach in and see if I can unplug that data cable, data plug. Yeah, very difficult getting in there. Right, I'll stop filming while I try and do that, and then we'll have a look and see what I managed to pull out. Right, I've managed to get that connector off. Okay, so it's got a little sort of press clip thing on it, and that has 3 wires. We've got purple or violet, and we've got what appears to be, this is not focusing well at all, purple and blue and green, and then what appears to be violet and black. Violet and black on this side. Having a look at the circuit diagram, we can see that the ground connection looks like violet, but there's no notation on it, so I think that's the violet and black. The ignition on wire, which looks like it goes to pin 1, is violet, and then the PWM, the pulse width modulation control wire, is blue and green. Okay, so blue with a green stripe. Okay, so what I need to do is, first of all, I'll check continuity on the ground wire. I'll then check that the ignition on 12 volt wire comes on with 12 volts, with the ignition on when I turn the key. And then there's this other wire. Now, I don't know what I'm going to be able to do with that. I don't have an oscilloscope, and I don't know what frequency the PWM signal runs at, but I could possibly connect an LED or something. At least then we'd see it flashing, maybe. Tricky to know what to do with that one. So yeah, okay, well, let me test the ignition wire and the ground first of all. We'll see if there's 12 volts and 0 volts on those. Okay, so what I've done here is I've just put a little crimp connector just into that leftmost pin there, leftmost hole there. I've connected that onto there. We'll just, first of all, before I try a resistance test, we're just going to try a 12 volt test. Right, there's no 12 volts. It's always best to try that first, just in case that is live for whatever reason. Otherwise I'm going to end up sticking 12 volts into my meter Right, so 12 volts into my meter on the resistance range, which will probably damage it. Let's stick that into there. Ah, there we go. Right, okay. So that pin, so with the barb here, the little clip upwards, that pin on the left, which this little connector thing, crimp connector is plugged into, is ground. So let's try the other one at the other end now. This is the violet one. Now I've got to be very careful here because I think that's going to be 12 volts. I've just got to make sure it doesn't touch any metal work. Hang on, what's going on? Forgot to change that. And what we'll do, we'll put that to 12 volt range, and I'll just carefully connect that onto there. Now that's 0. So what I'm going to do now is stick the key in, turn the ignition on, right, there we go, 12 volts, okay, so that's 12 volts now. I'm just going to turn off the ignition, okay, and that's gone off. Okay, so that rightmost pin, the one I'm connected to now, is ignition on 12 volts. That means that the one in the middle is the pulse width modulation signal. Now the good news is I'm getting 12 volts with the ignition. So one by one we're ticking these connections off. So we've got ground, we've got the high current 12 volts, we've got ground on the signal connector, and we've got ignition on 12 volts. The only things left to check are the pulse width modulation wire and the actual element itself, because the element could be blown. I suppose the third possibility is that it is working, and it always has done, and I've just really not felt any increase in warmth from the vents. So I have heard that the heat output of these things is not great, and on a freezing cold morning with air blowing out of the vents, you really don't actually feel any difference when this thing's on. I'm not sure really. Maybe I could get a little aquarium thermometer and put a probe in there and actually see if the temperature increases. So yeah, so okay, right, what I'll do now is I'm going to try and measure the pulse width modulated pin, although it's not that great. It is cold at the moment, but it's not below 0. It's about 3 degrees at the moment. Now my meter does actually have a frequency range there which we could use. I think it might be better to actually just put that on 12 volt DC and just see if it flickers, just see if anything happens at all. This is going to be one of those difficult ones to try, really. Let's see if I can get that into there without, there we go. Okay, so that's now on the middle pin. So let's just put that, oh, hang on a minute, what's going on there? We've got some, well, that's interesting. Let's put that on the 20 kilohertz range, and we're actually getting 3.8 kilohertz. That's a very, very high frequency pulse width modulated signal. I wonder if that's just noise or interference or something, or whether or not that actually really is. Disconnect it and it goes off. So okay, all right, it does appear to be a high frequency signal on that middle pin. I guess that possibly suggests that the heater itself is no good. Yeah, difficult to know what to do now, really. could do, I suppose, is use that spare one, try it on that, just rig it up with some jump leads and try it, and just see if it actually gets warm. Maybe that's what I need to do. Okay, this is certainly proving a little bit more difficult than I thought it would be. Okay, so what I've decided to do is actually use one of my jump leads to connect up the spare heater element. Okay, so I've put a small bolt into that connector there, very carefully connected on the crop clip for the jump lead. Got to be really careful that that doesn't start touching any of this metal work. Otherwise we'll be testing out that 100 amp fuse again. That lead goes round to the other side and is connected very carefully into there. I'll just put a socket carefully in there, again making great care not to short out onto that metalwork. Now if I just turn on the light, so I've plugged in the three-way plug and I've plugged in the negative, so this element is now rigged up to my car instead of the other one. Okay, now the ignition's not on at the moment and that's not getting hot. What I'm going to do is turn on the ignition and we'll just see if there's any warmth coming out of that. Just feel that and see if anything gets warm. There's no heat coming out from it. It isn't getting warm. I just don't think the weather is cold enough at the moment, even though it's going to snow tonight. I think this only comes on if it's sub-zero. So what I might do is disconnect this and come out later on, because it's going to be about -3, -4 tonight. Come out later on and we'll just see if anything happens. I wonder if I have to start the engine. Yeah, actually thinking about it, it probably doesn't want to pull 100 amps from the battery when the engine's not actually running. Okay, so that maybe I need to start the engine up. Alright, let's start the engine and we'll just see if anything turns on. Right, engine's running. Still no warmth from that. I don't know if it's my imagination. That is actually getting warm. That's getting warm. That is getting warm. I can feel it. That side is not very warm. That side is getting really hot. Okay, it's getting hot. Right, let's turn that off. Right, well that was a successful test. That's pretty hot now. Just about keep my hand on it. That is nice and toasty warm. Right, okay, well, that is interesting. So, that element works. It works connected to my car. That means all the wiring, all the commands, all the fuses, everything is correct and is rigged up to work. That is got nice and warm. So I think the most likely thing here is that my PTC element is either faulty or it is also getting warm and I'm just not feeling it at all. Okay, what I'm going to do now is I'm going to put everything back as it was, connect my one, the one in here, connect that, reconnect that up, and I think really I need to get a thermometer and actually, because I can't get to it to feel if it's getting warm, but I might be able to put a probe or something up there to actually see if it heats up kind of quicker than the engine heats up, really. Okay, all right, next challenge. So what I'm going to do now is I'm going to start the engine. I'm going to dial up full heat on the two knobs there, and I've disconnected the positive cable from the PTC element. And then when the engine's running, I'll just reconnect it and we'll see if we hear any sort of change in the revs or the note from the engine. We'll just see if there's any loading, because this heater element is meant to draw like 50 to 100 amps. If you put that kind of current drain onto the battery and the alternator, you will hear a change in the engine note. You don't get something for nothing with energy. The energy has to come from somewhere, so it puts a mechanical load onto the engine when you are using more electrical energy. Okay, so the alternator actually becomes more difficult to turn if it's generating a high current. So we'll hear that. So yesterday, when I connected up the spare element, I had these knobs here set to about 25 degrees, I think it was. They weren't on full hot. I didn't have a heated screen on, and I didn't press this prog button here. So this is interesting, because a lot of people have told me that in order to get the PTC heater to heat up, you have to press this prog demist, the programmable demist button. But yesterday it was heating up without that button being turned on. All this button does is it just puts full air on the windscreen for a set time, and then I think it automatically goes off after a while. But when you turn that off, it'll go back to sort of everything it was set to before, as far as sort of feet, screen, and fan speed. Now, one thing to note with this button here is it doesn't adjust the temperature. Okay, so it doesn't actually go to full heat. You still have to turn these up. Now, I've also heard that in order to get the PTC heater to turn on, you have to turn these fully on. But I don't think that's the case. Okay, because they were on 25 degrees yesterday, and the heating element was still getting hot. So it's not triggered by prog, it's not triggered by either of the demist, front or rear screen demist, and it's not triggered by putting the temperature dial onto maximum. It just is automatic. The car will work out if it needs the PTC heater. Now, it'll measure the ambient temperature, so just at the bottom of the wing mirror is a small temperature probe. It will know the interior temperature somewhere down here. You can just about see it down there. Down there is a little vent that's actually got a thermocouple or thermistor in it to measure the cabin temperature. Now, if the car is cold, the water temperature is cold, the outside temperature is cold, then once the engine is started, the ECU will tell that PTC heater to turn on for a time, and then once the interior of the car warms up, it should turn off again. So what I'm going to do now is start the car. The only reason I've put those dials up to maximum there is just to make sure that the PTC actually gets used. Okay, so let's start up now. Okay, right, so we've got full heat and it's on auto fan, so we're not hearing any sort of air blowing yet because the engine's cold. So let me plug this in and we'll see if there's any change in engine sound. Right, that's it, that's plugged on. Nothing happened at all. Didn't hear any change in the revs, any change in the note of the engine. So I don't think it's drawing any current. I don't think there's any current flowing through that PTC element at all. Now, one other thing I could do is use my meter here and actually measure the resistance across the element. Now, can't really do that with it turned off because it will be very, very high resistance, because don't forget the high current terminals are permanently connected to 12 volts and ground. So if there was any current flowing at all, it would flatten the battery. But what we can do is measure the resistance whilst the engine is running, and then the field effect transistors or whatever is inside the top of the unit should actually cause the resistance of the element to drop to quite a low value, okay, especially when it's cold. Don't forget it's PTC, positive temperature coefficient. The hotter it gets, the more the resistance. So we should actually see that on the meter here. So if I put that into sort of a 200 ohm range there, so we should see, if the element is good, we should see a low resistance to start with, very low resistance when it's cold, and then it should slowly rise as the heater warms up. Now don't forget the element itself is not connected to the high current wire, so it won't actually start to warm itself up, but as everything warms up we should see that resistance drop. We'll have to see, we'll have to connect it up and see what happens. Okay, so I've connected my meter across the element, okay, and that is showing a resistance. There we go, so that's high resistance at the moment, so it's on the 200 ohm range. So let's just start the engine and just see. See if anything happens there. Nothing at all. We'll just let the engine run for a moment and just see if anything happens. What I would expect is the resistance to come down. Let's just try messing around with these just to see. They weren't on yesterday, and the other one was getting warm, so I don't think you need these. Let's prog. No. Those are both on, fully on. We'll just to simulate exactly what we had yesterday, let's put those to 25. Still nothing at all. Okay. So just as a quick comparison, I've put in the spare element here with the signal connector plugged in, and then I'm just measuring the resistance across the element there. So if I just reach up, turn on the ignition, we're not seeing anything. Now if I go round and start the engine, see if that changes. Still not changing. This is definitely connected. I'm not sure if that's really going to work. Still showing high resistance, and yet yesterday that was working fine. So what I'm going to try next is actually measuring the current that is flowing through the PTC heater element on my car, the one that's on the car currently. Could also try measuring the current through this one and just see if there's a difference. That'll give me a clue as to whether or not my one is faulty. What I've bought here is an ammeter. This is a 0 to 100 amp meter. Now, looking at the back of this, there's absolutely no way that this meter can take 100 amps flowing through it. It's got very, very small little terminals on here. Now, when we look at the display, we can actually see this little symbol here. There's a sort of small, what appears to be a resistor with 75 millivolts written next to it. What that indicates is that you need to use a shunt. Okay, a shunt is a kind of almost a short circuit. Okay, so this is a steel bar with a very, very small cut in it. What that will do is it will send most of the current through here and a very small amount of current through the meter, and the meter is then calibrated to work with this shunt. So somewhere on here we can actually see 100 amp 75 millivolt. The idea is that the resistance of this, whilst the resistance is incredibly low, it's enough to develop 75 millivolts across this resistance when 100 amps is flowing. And then this meter is just a 75 millivolt voltmeter, but because we're using it in conjunction with this shunt, the scale can then be calibrated as 0 to 100 amps, and what flows through between these terminals with the meter connected will then be shown on here. One way to think of this is a little bit like, imagine you've got a river flowing, and in the middle of the river is an island, and 99% of the water flows on one side of the island, a very small amount flowing on the other side of the island. Maybe on that small channel there is a mill with a water wheel. The speed of the water wheel will give us an indication of the overall flow of the river, because we know that a small amount of whatever's flowing is going on one side. It's exactly the same with the electrical sort of equivalent. 99% of the current will go down here. A small amount, it may not be 1%, but let's just call it 1%, will go through here. Okay, it's probably actually a lot less than 1%, probably 0.001% or something like that, but whatever goes through here is enough to deflect that meter. So what I need are some low current crock clips. Okay, so I will connect the meter up using those. We've got red and black, and then we've got my jump leads here with very, very high current jump leads. These will easily take 100 amps. They're designed for jump starting a car. So I will connect these jump leads to the big terminals, or probably to the whole metal end of that actually. Maybe use these bits for the smaller ones, and then wire the whole thing in series with the cable that feeds the positive side of the PTC heater. So the 100 amp or up to 100 amp current will flow from the battery down the red cable into the heater, through here, triggering the meter into the black, and then into the terminal on the heater. And then whatever flows through the heater will be shown on this gauge. Okay, now it's about -2 at the moment. It's a very cold winter's night. We're in the middle of a bit of a chill at the moment. The temperature is not really going above 0 during the day, and tonight is going to be about -5. So perfect time to test this out, because my thinking is that the PTC heater element only gets turned on by the car when it's very cold. From what I've seen so far, I think it only comes on when it's below 0. I tried doing this test this morning just as a sort of a quick check to see if it would even work, and the temperature outside was about +2 degrees and no current flowed. Now that either means it was too warm or it means my heater element's broken. Okay, so now that it's below 0, I'm going to repeat the test and see what happens, see if we get any current flowing. Okay, so what I've done here is connected my jump leads to either end of the shunt, and then put the small crock clips to the meter. Okay, so they're connected in on the back of the meter, and then down here, very carefully, I have put a bolt into there. Now I need to be really careful because this is connected to the battery. That is permanent live high current 12 volts. If that touches this, we're going to get a lot of smoke. So that is there, just an M6 bolt stuck into there, and I've just stuck a drill bit into the connector there. It's the only thing that I could find that would fit in alongside the terminal there. So now I need to very carefully connect my jump leads crock clip to there, and then this one to there. Okay, so the current will flow from the battery through the 100 amp fuse down the red cable, through the shunt, small amount going through the meter, through the shunt, black cable back into that drill bit and into the heater. Okay, so if the heater is turned on by the car, we should see, if the heater is working, we should see a deflection on the needle there. Okay, so let's find the keys, start the car, and see if we get anything on our meter. Okay. Right. Turn off the headlights. Right. Seeing. Oh, I think it's going the wrong way. Hang on, I think I've got the meter around the wrong way. Come on. Okay. I think the needle is trying to deflect. Right, there we go. Look, there's definitely something there. Just to prove it, I'm just going to disconnect that. There you go. Oh, come on. There was definitely a current there. There's definitely a current there. It's gone now. Come on. Right, let's just turn up some heat. Right. Is it me, or is that needle wobbling about? Right. I thought that was reading a current. Let's just make sure the crock clips, yeah, they've not fallen off. Okay, so let's try now pressing prog. Now we heard the revs drop there, but that's because it's turned on the heater screen as well. Okay, no current. Turn off prog. Heated seats, no. Air conditioning, no. There was definitely something going on there. The needle was definitely moving. I'm thinking it's because the engine's not stone cold. Drove the car about half an hour ago, so the air coming out of the vents is already warm. Because of that, the water system in the car, because the water system's not that cold, the yeah, you can see the gauge there. The temperature gauge it's not operating temperature, but it's not stone cold. It's not a cold start. Okay, right. Okay, I'm not sure what to do now. I might have to just leave this until later tonight when everything's cooled off. It shouldn't take that long in this weather. Okay, so I decided to leave the second attempt until the next morning. It is quite a nice sunny morning here, but it was about -5 last night, and it's still below 0 now, even though that car doesn't actually look that frosted up. I think it must be just very dry air at the moment, but it's sort of hovering around 0. So I've reconnected the crop clips there. Everything's still connected there with our shunt and our meter. The coolant in the car will be very cold now, so I'm going to start up and give the glow plugs a chance to heat. Right, now, is anything going to happen? It is moving. It is moving. It's coming up slowly. Not a lot, but there's 5 amps, 6 amps. Okay, so this is very interesting. The current is slowly increased. I think what is happening there is the computer is giving the alternator a chance to recharge the battery a little bit. So when the car first starts, the voltage will be dropping off as the battery is cranking over the engine, and then once the engine is running, the alternator's given a sort of a minute or so to just put a bit of charge back in, and then that pulse width modulation waveform is slowly changed into a sort of more on and off square wave. So the duty cycle of the square wave is increased, and current starts to flow. Okay, so we've got 10 amps there. So if even though I've put these are up to max here. Now I'm just going to try something. I'm just going to put these to cold, and we'll just see if that drops back off. Yeah, it does. Yeah, it does. Look at that. Look. Okay, so let's put these back to hot, and we should see that come back up. Should do. It is rising. Yeah, it doesn't move very quickly, but it is coming back up. Now I'm going to press the prog button, okay, and see if anything happens. Now that's interesting actually. It's actually gone down, not up. So all those people who said that prog turns on the PTC heater, sorry, you're wrong. It's turned it off. The revs dropped a bit there due to the heated screen, so I'm just going to turn those off but leave prog on. No, it's still completely off. Okay, so let's go back to regular heat, and we see it coming up again. Well, amazing, amazing. I've heard so many times from people who say that you have to press prog to enable the PTC heater. No, it's fully automatic, but is dependent on the temperature that you dial up here. So if we put 20 degrees, that's still up, because 20 degrees is quite high compared to ambient. But if I put that to say 16, I mean, ambient temperature outside at the moment is -1. Okay, now even at 16 degrees it's still high, but if we go down to fully cold, let's turn the fan down. There we go, it drops right off. Okay, so fully hot. Let's go full blowers. And that is starting to come back up again. And what I'm going to do is put it onto there, and I can actually feel, yeah, so I can feel there. Now, that is drawing a current. The engine's been running for about 5 minutes now, so I mean, I wouldn't call that air warm, but it's not freezing cold. It's not -1. It's, well, I'd have to get a temperature probe to tell you exactly what it is, but I would estimate that to be around probably about 10 to 15 degrees. It's just sort of like lukewarm kind of air. That might be purely due to the water heating up in the car. I don't know. I mean, the element is drawing current, so one would assume it's actually getting warm. Okay, good. So the good news is it looks like my heating element isn't broken. It is drawing 10 amps. It's a lot less current than I thought it was going to be. This is on a 100 amp fuse. Maybe if it was even colder outside, that current would be higher. I'm not sure. I may try connecting up the spare element and just see if that's drawing a similar amount of current. But yeah, okay, that's good. That's good. At least we're seeing current now, so it shows that something somewhere is working. Okay, right, on to the next stage. Okay, final part of this video. It's freezing cold, it's raining. I need to go inside and warm up. So I'm going to try and wrap this up. Okay, there are a lot more things that I want to try, but they may just have to wait for another day. So what I've done here is connected the positive cable out through the shunt with the meter very, very carefully to the positive terminal on the spare heater. Okay, the negative is connected with its normal plug, and I've also connected the control connector. The reason I've got this panel here is because this is permanent 12 volts, and if this comes off, if this wasn't here and that touched the metalwork that is down in there, which you can just about see, then there's going to be a big flash and a bang. So just got to watch the sort of electrical safety of it here, because there is a lot of some very high currents available to cause a lot of damage if we're not careful. So the reason why I've connected up this spare PTC element now is I believe I'm finally understanding how this works. Okay, and by connecting this up here, it will show if there's any difference between that one and the one that's inside here. The way I think this works is when it's very cold outside, probably below 0, the PTC heater inside here is put on when you dial up a high heat, but not the heated screen. Okay, so you can press prog if you want, okay, but you do need to turn off the heated screen. Okay, so what is going on there? Well, a lot of people always said, oh, you have to press prog to get the PTC to fire up. Well, that's partly true. That is partly true. On vehicles that don't have a heated screen, so that's the Freelander 2s without the cold weather pack, the PTC will get warm with prog. It'll get warm even without prog. It gets warm when you start the car and you ask for heat, and the water in the coolant system is not heated up yet. The PTC gets warm. But those cars that are equipped with a heated screen, there's not enough current available to run the heated screen and the PTC. So if you press prog and your car has a heated screen and that comes on, the PTC will turn off. That is why yesterday I saw the current go back to 0 when I pressed prog, and I thought, oh, hang on a minute, everybody always says you have to press prog to get the PTC to start. Well, it will start automatically with or without prog, but the minute the heated screen comes on, it turns back off again. So that's why I saw a current reading, and then it went to 0 again when I pressed prog and the heated screen came on. So what I want to do now is not only check that I get the same current here with this one, so it was about 10 amps. Now remember that it's a square wave controlling this, okay? So this meter is going to show the average current. The actual peak current will be higher, but let's not worry about that for now. This is an analog meter, okay? So it will give us sort of a kind of a damped reading, give us a sort of an average current reading, okay? So the control pin in the control connector is a square wave. It's very high frequency, about 20 kilohertz pulse width modulation signal, okay? So that's a square wave turning on and off, turning the heater on and off very, very rapidly. And the longer that the wire is on compared to off, the more heat comes out of it, okay? So we are just looking at average current here. Now, when I ran this yesterday, I started the car, we found that on cold there was 0, and then I put it up to hot and we got about 10 amps average, okay, average. And then when I pressed prog and the heated screen came on, it went to 0. So let's just try that again with the other one, see if we get the same results. Okay, so let's just start up. Okay, right, okay, so are we getting any current flowing? No, we're not. Oh, no, yeah, no, we are now. It takes a moment to get going. Okay, so there we go. Now, that should rise to about 10 amps. No, oh no, it's going a little higher. Okay, well this is interesting because the one in my car only went to 10. Okay, and it's not actually as cold today. Yesterday was around sort of -1. Today it's about 2 or 3 degrees positive. So it's actually a bit warmer today, although it doesn't feel like it. Okay, so there we go. We've got 20 odd amps. Now, what I'm going to do now, first of all, I'm going to feel that. Ah, Jesus Christ, that's very hot. Okay, that is hot. Right, so prog with heated screen. We should see that drop off. Yes, we do. Yes, we do. Okay, that's dropping back off. And now I'm going to turn off the heated screen, but leave prog on. And we should see that go back up again. Yeah, it's going back up. Okay, and then just to prove that it isn't dependent on prog, we'll just turn prog off. Okay, and it's continuing to go up. Rear screen makes no difference at all. Okay, so the rear screen is not part of the equation. Okay, so that heater there is, I can feel the heat coming off. I'm not even going to touch my hand on it. My hand is about a centimetre away from that, and I can feel the heat. Okay, so that's getting pretty hot. I need to be careful I don't start melting the carpet or whatever that's against. But okay, so as the car is starting to warm up, that current is dropping off a little bit. We've now got 10 amps. Let's just play around with temperature here. Let's set to 20 degrees, right, and see what happens. 20 degrees, yeah. So that 20 degrees is a lot hotter than the outside, so it's still drawing current, but let's put that to full cold and we should see that drop off. Yep, that drops off, and the blowers are blowing because, yeah, it's cold outside. So, okay, right, so let's go back up to say 25 degrees, 25 degrees, and we should see that start to come up again. Yep, it's coming up. And then heated screen only on, and it drops back off. Okay, that is conclusive. That is conclusive, all right? You don't need prog, but you do need the heated screen off, okay? And to test that theory, I actually went for a drive earlier. Turn this all off now. I went for a drive earlier and I didn't use my heated screen. I didn't use the heated screen. I just dialed up 25 degrees on here, used the heated seats, I used the rear demist, but didn't use the heated front screen. And do you know what? After about 100 yards, I could feel warm air blowing. It wasn't hot air, it was lukewarm, it was warm compared to the outside air. And I suddenly realised what I've been doing all these years. I've owned this car for like 8, maybe 9 years now. Whenever it's cold, I hop in, start the car, heated seats, full hot, heated screen, heated rear screen. I don't bother with prog. I've never used prog because it just doesn't actually seem to really help. But I do use my heated screen all the time when it's cold. The only time I don't use it is in the summer. And even on a summer's day, if it's a bit humid and rainy, then you still want the heated screen. So always use the heated screen. I just turn it on out of habit, and it comes on for a few minutes and then it goes off, and by that time the engine's warmed up. So the PTC never actually does anything. It never has a chance to kick in. But then when I tried it earlier without the heated screen, I could actually feel warmth coming through. And I'd only gone like 100 yards up the road. Not enough time for the engine to warm up. The temperature gauge was still reading cold, and yet warm air was coming out. So my PTC heater is working. It is working. I just didn't know how to make it actually come on. Now I realise that. So I'm going to end this video now, but another day, and I'm going to try and do a part 2 of this video, another day I'm going to actually get a temperature probe and I'm going to stick it sort of in here, and we'll actually start the car without the PTC connected, without heated screen and all that, and just start the car, and I'll plot a graph of temperature versus time as the water system in the engine heats up. Okay, then we'll try it with the PTC connected but without the heated screen. We should then see a difference in the rate of heating. It should heat up a lot quicker. And then we'll do PTC and heated screen like I've been doing for the past 8-9 years, and see what we get then. Okay, just see what we get then. Is it any different? Is it one or the other, or halfway in between the two? I don't know. I will try that. The reason I can't do that now is my engine's already been started, it's already warmed up a bit, and the weather forecast for the next sort of week or two is actually not that cold. It's like 13 degrees or so, so the PTC is really not going to do a lot. Okay, so I need to wait for the next cold weather. So the next time there's some cold weather, I will repeat this test and we'll actually measure the temperature. And then, once I know my PTC is definitely working, actually plot a graph and actually see a difference and know, scientifically proven, that it's definitely working, I'm going to try to take control of the control connector. Okay, so I'm going to try and actually override the signal from the computer, from the ECU, and have some kind of manual override switch or a button that I can press, and the heater goes to full blast. Now, I may need some kind of pulse width modulation control device to drive that. I might possibly be able to just take that pin to permanent 12 volts and just go for a sort of 100% duty cycle square wave. I'm not sure. I don't know. I don't have time really at the moment to do that. I've got many other YouTube videos to film. So we're going to leave that for another day. All right, we'll leave that for another day. But the good news is, I think my heater is working. It's not drawing quite as much current as that one, but there is warmth coming through. I just need to remember to use either the heated screen or the PTC. You can't have both, and that will be something I'm going to try and change in the future. I'm going to try and actually modify this so that I can have both. Now the current drain will be high, okay, so there's another problem there. Okay, so I need to sort of make sure I don't flatten the battery or whatever. So plenty more to think about, but the good news is we understand how this works now, and I can enjoy lukewarm air from my air vents if I want them. So if I want that. So okay, I'm gonna end this video. I hope that was useful, and I will see you in the next video. Thank you very much for watching. Thank you. Bye.